Hello everyone, welcome to Limiting and Excess Reactants. This is the sixth video in the scale factor stoichiometry series, and let's go ahead and look at what you need to do to be successful in this video and what you'll learn from it. In order to be able to understand what's going on here, you need to understand how to do mass stoichiometry using the scale factor method. This has been covered in the previous videos, and so if you are ready to go on, let's go ahead. If not, I recommend that you please go back and watch the first 5 videos in the scale factor stoichiometry series. Otherwise, you'll have a hard time understanding what we're doing here and why. After we're done, you should be able to define limiting and excess reactants. You should be able to determine which chemical will be used up first in a reaction, that is your limiting reactant, and you should be able to determine how much of an excess chemical remains. Let's get on with the show here, and instead of cookies, we are going to do pancakes, and I have a reason for that I will not get into right now. Here we have a recipe for pancakes. It calls for 2 eggs, 2 cups flour, 3 tablespoons of sugar, 1.5 cups milk. And as we look through our pantry and our fridge, we find that in our house there are 12 eggs, 10 cups of flour, 120 tablespoons of sugar, and 1 gallon, which is 16 cups of milk. So we're trying to make as many pancakes as we can. How many is that? Which ingredient are we going to run out of? Will it be the eggs? Will it be the flour? Will it be the milk? Or maybe the sugar? And then once we've run out of that ingredient, how much of my other ingredients are going to be left over? What kind of a shopping trip am I going to have to make to restock my pantry and fridge? So let's go ahead and look at how we solve this problem. We're going to look at the scale factor for each ingredient. The eggs allow me to make a size 6 batch. The flour allows me to make a 5 batch. The sugar allows me to make a 40 batch. Wow, that's pretty impressive there. And the milk is enough for a 10.7 batch. So what we can see is that the flour has the smallest scale factor. It limits us. We are limited to a size 5 batch by the flour. And so that means the other ingredients are in excess. And with the flour, that's right, we need to cancel our units. The flour will limit us, the other ingredients are in excess, and we will be making a size 5 batch. Let's go ahead and see what that looks like. So there is the standard recipe written out in chemical equation form, and with a scale factor of 5, we will just multiply everything in there by 5, and that is our rescaled recipe. That will allow us to make a total of 100 pancakes. So that's a decent number. We should be able to feed a lot of people with 100 pancakes. Now what about the other question, which is ingredients in excess? Well, the recipe called for 10 eggs. Once we scale it up, we have 12 eggs, so 2 eggs excess. Recipe will use up 15 tablespoons of sugar, so subtraction tells us we have 135 tablespoons excess, and then the same process for milk. So to get the excess ingredients, we do a little bit of subtraction, and then we find out how much we have left over. We'll be using the same process for chemical reactions. You get multiple scale factors, and then the small scale factor tells you which reactant is limiting. And then you can rescale it, and then from there you can do a little subtraction to find out what you have left over. Time for a problem. How many grams of solid silver can be produced from 2.5 grams of copper and 8.5 grams of silver nitrate? What reactant is limiting? How much excess chemical remains? So here we go. Mole balanced equation. Turn the mole balanced equation into a mass balanced equation. And now, in the past, we've always just been told about one chemical, 2.5 grams of copper. And we just assumed that we had enough silver nitrate to finish the job. But we're not assuming that anymore. We have 8.5 grams of silver nitrate. And that might not be enough, or it might be too much. That's what we need to figure out. So what we're going to do is we need to get the silver nitrate scale factor and the copper scale factor. Standard value for copper is in the equation, standard value for silver nitrate in the equation. Copper scale factor. Situation over standard gives us a scale factor of 0.03937. Silver nitrate scale factor, 8.5 grams over 339.8 grams, gives us a 0.02501 scale factor. So we can see that silver nitrate has a smaller scale factor, and that is what's going to limit us. Silver nitrate is the limiting reactant. Take that scale factor and apply it to the entire equation, and let's see what comes out of that. So there's the question again, just to keep it fresh in our minds. And when I apply the scale factor to the entire equation, out come these values. So this reaction will use 1.59 grams of copper. It will use 8.5 grams of silver nitrate, which is perfect because that's what we thought should happen. We will make 5.4 grams of silver, and that's what the question asks us. How many grams of solid silver can be produced? So we can make 5.40 grams of silver. What reactant is limiting? Well, we figured that already. That was the silver nitrate was limiting. How much of the excess chemical remains? So we need to do some subtraction now. We use 1.59 grams of copper. We need to do a little bit of subtraction, and we find that 0.91 grams of copper will still be in our container. That is the only example I'm going to show you, and we're going to go straight to practice now. So we have a ninja chemist. Ooh, this is a new twist. Perhaps she's going to hunt down our chemist who was working on the black market in the last video, and we'll see what becomes of him. Adds 2.5 grams of zinc to a solution containing 12 grams of silver nitrate. How many grams of silver can she expect to see appear before her ninja eyes? And how much of the excess chemical will remain unreacted? You know, we haven't seen any ninja chemists hanging around, but that would be how a ninja... Oh, she wants to let us know that she has been watching us for who knows how long, who knows how many videos she's been with us here. But now that we're actually talking about her, there she is. Okay, you can go ahead, Ninja Chemist, and do what Ninja... Oh, there we go, okay. What ninjas like to do. All right, please pause the video now and work through this problem. Rewind if you need to. You can go ahead and go back a minute or two and look through the process that was shown you earlier. Please try to figure out this problem. The Ninja Chemist and I will wait for you, and we will be here with answers for you once you have finished your work. Okay, welcome back. I hope you were able to solve this problem. I hope you have taken the few minutes. I hope you did not just blast through that pause there, because it's always valuable to work through it on your own. So here we go. This is what I did to solve this problem. There's the mass balanced equation for you again. There's zinc's scale factor. There's silver nitrate's scale factor. And we can see that silver nitrate has the smaller scale factor. We will apply the smaller scale factor to our whole equation. And this is the zinc that will be used, the silver nitrate that will be used. And look at that. That's all of it. Okay, and we will make 7.62 grams of silver, and then our excess zinc is the difference between what we had and what we used, 0.19 grams of zinc, and our ninja chemist is, oh, there she is. Our ninja chemist is very happy to have her 7.62 grams of silver that I don't know what she's going to do with it, but would you be so kind, ninja chemist, as to cancel our units out? Thank you. Okay. I hope this video has been helpful for you for limiting an excess reactant, and I look forward to seeing you in our next video where we will learn about percent yield. Till next time.